Our topic for the moment is the range of a function. So to define a function, we'll let x and y be two non-empty sets. A function from x to y is a relation that associates with each element of x exactly one element of y. The set x is called the domain of the function. For each element x in x, the corresponding element y in y is called the value of the function at x, or the image of x. The set of all images of the elements in the domain is called the range of the function. So here we have a function. It's a segment for every x. There's exactly one y value, so it meets the criteria for the definition of a function. And its domain is the set x in set builder notation. Now the smallest element in the domain is 1. The largest is 5. So 1's less than or equal to x, which is less than or equal to 5. As to the range, those are the corresponding vertical coordinates, and the smallest, y, such that vertical coordinate in the graph is 2, and that's less than or equal to y, which is less than or equal to the largest y coordinate in the function is 4, and we're done with that function. Now here we have another function, except the endpoints have been excluded. So now the domain equals the set x such that, and x is bounded below by 1 but does not include 1, and bounded above by 5 but does not include 5. As to the range, that's the set y such that, and y is bounded below by 2 but does not include 2, and bounded above by 4. And notice, we have equal signs associated with these two inequalities. We do not have equal signs associated with these two, and also correspondingly we have open circles here and no equal signs. We have closed circles here and we have equal signs. Here we have two more examples of functions, and for our friend on the left, the domain equals the set x such that, and we have a minimum x coordinate, but we have no maximum x coordinate. This ray goes on forever. It's going to have an infinite number of x coordinates to the right, and it's going to have an infinite number of y coordinates above. So the domain is x such, or the set x such that x is greater than or equal to 2. And the range, by looking at the graph, we can see that the minimum y value is 1, but there is no upper bound on the corresponding or subsequent y values, and so we have the set y such that such that y is greater than or equal to 1. Now for this function, whose equation is y equals x plus 1, and correspondingly has the intercepts, a y-intercept at 0, 1, and an x-intercept at -1, 0, its domain equals the set x. Now notice, all x coordinates to the left of 0, the x coordinate 0, and all coordinates to the right of 0 are part of the graph, are components of the graph of this function. So the domain is all reals, or in set builder notation, x element of the reals. Correspondingly, the y values include all those above 0, including 0, and all corresponding y values below 0. So the range is all reals, or y element of the reals. Finally, we have two functions about which we must find the range. The first is a quadratic function, f of x equals x squared plus 1. The second is an absolute value function, g of x equals negative times the absolute value of the quantity, x plus 5, close the absolute value plus 3. Now, as to the domain for f of x, the arrows indicate that this function is not only going up, but also spreading left and right, and such that all real numbers are candidates for x. So the domain is all reals, or in set builder notation, the set x such that x is an element of the reals. As to the range, the graph of the function indicates that the smallest or least value y can take on is 1. So y such that, and all other y coordinates are greater than 1. So the range is y such that y is greater than or equal to 1. And our goal here is for the student to be able to look at the graph and recognize the range. The smallest y coordinate on the graph of f of x equals x squared plus 1 is 1. Consequently, the range is y such that y is greater than or equal to 1. Now for our absolute value function, the domain equals x, and again the arrows indicate that this function is not only going down forever, it's also spreading to the left and to the right forever. So every x, or every real number, is a candidate for x. So our domain is the set x such that x is an element of the reals, or all real numbers. As to the range, that equals y such that, and the maximum y value associated with this graph is 3. All other y values are less than 3. So the range is the set y such that y is less than or equal to 3. And let's review that one more time. If you look at the graph, the largest y value associated with this graph is 3. All other y values are less than 3, and so the range is y such that y is less than or equal to 3, and we are done.